Okay, we're back on the second half in this, and this is to talk about actually the stoichiometry, or what I like to call the cookbook chemistry, which is just using the mole ratio, the recipe. That is your recipe that tells you how much of one thing you're going to need to react with another to produce a certain amount. On the problem that I put up in the last video, I had made a mistake. I had a nitrate right here. That should say chloride. So if you wrote that down, which I'm hoping you did, please change that into a chloride. So the first thing you need for any of these, you have to have a recipe, which means you need to write a balanced chemical equation, which this is good practice. You need to know this for the test anyway. So let's go ahead and break this down. How many grams of magnesium chloride are produced? So if those things are, if magnesium chloride is produced, you know it's going to go on the right hand side because those are your products, right? And now what do we write for magnesium chloride? Magnesium chloride. But you should know, oh, magnesium's in group 2, so it's a +2. Chloride is in group 17. It wants to gain an electron to be like a noble gas, and so you know that it's a -1. And so we're going to have 2 chlorines for every 1 magnesium. Oh yeah, just like we did right up here. Okay, it's the same one, which makes sense because when we did our empirical formula, it told us it's magnesium chloride. Well, because it's based on this, the electrical charge of magnesium and chlorine. Okay, so let's go on with the rest. So what else is in this problem? Is produced if you have 3.5 grams of magnesium reacted with hydrochloric acid. All right, so we've got magnesium and we have HCl. So obviously that's all since that's all that's written, we're done, right? Because, you know, if there aren't any more words, there can't be any more stuff. Unless you realize that on the left-hand side we have hydrogen and we don't have it on the right-hand side. You are violating the laws of physics. Do not do that, people. That makes me angry. So in this hydrogen, what are we going to have to put on this other side? H2. Why 2? It's part of the HNO7, and it has to be 2 by itself. Again, all these things from Chem 1, these things that, you know, should ring a bell. Next step, is it balanced? No, still violating the laws of physics, so let's correct that. We've got 2 here, need a 2 here, and now we're all good to go. Okay, so I'm going to go ahead and set up my, I'm going to rewrite this up here so then I can organize my information in the actual problem. Okay, so the whole point of this, we're trying to figure out how many grams of magnesium chloride are made, correct? And we're starting with 3.5 grams of magnesium. But we, of course, want that to be moles of magnesium. And so this time we're going from grams to moles. And how do we go from grams to moles? Oh, we just did that. Divide by the molar mass, okay? And so, and we already, since we just did in the previous problem, we know 3.5 divided by 24.31 equals 0.14. So we're starting with 0.14 moles of magnesium. Now, in HCl, we have plenty of it. We have plenty of it. It says it's excess. We have gads of it. We have more than we need. And so, in this case, but just because I like to fill out my table, how much is actually going to be needed? How much HCl do we really need? How many moles of it? Well, it's a 1:2 ratio. So how much are we going to need? Well, we're just going to need double of that, which would be 0.28. Okay? So in order to get this reaction to completion, that's how much we would need, but it's telling us that we have excess, so we're good with that. And of course, we don't have any product at the beginning. Next, that was initial. Okay, so it changes, right? Something changes, the reaction occurs, and we produce what? We produce product. And so how much product do we produce? Well, what's going to dictate how much we get here? We already said we had excess HCl, so it's going to be the magnesium chloride that does that. So now we need to look at our mole relationship. For every 0.14 moles of magnesium, it's going to make 0.14 because it's a 1:1. That's easy enough. Okay, so we're going to make 0.14. Let's just go ahead and look at the other one, at the other product, in case we wanted to know how much hydrogen. It's how much? Oh yeah, 0.14. And so this is going to go away. And how much are we going to end with? Nothing. And if we're going to take away that much of this, we're going to be left with 0.14 moles of both magnesium chloride and hydrogen. The problem is only asking for how many grams of magnesium chloride are produced. So we really only need to do that one. But you know how many of the problems, and it's not just one thing that you need. You need to know multiple things and multiple questions. So you might as well just set it up, because then quickly you can kind of just use the table just to suss out, oh, well, how many grams of that? Oh, how much is left over? All that kind of stuff, especially when we get to limiting reactant. So anyway, but now that we have 0.14 moles of magnesium chloride, the question's asking for grams. Well, how do we go from moles to grams? Moles to grams, we multiply by the molar mass, okay? Again, easy enough. Grams to moles divide, moles to grams multiply. Know that inside out and backwards. It should be automatic, so you don't even have to think about it. And so we need to have our molar mass of magnesium chloride, which is, we got 2 chlorines, so that's 70.9. And we have our magnesium at 24.31. So this is 95.21 grams. And so we're just going to multiply that by 0.14. And so we know we're going to produce 13.3. I'm going to just stick with that number of significant figures. Not quite right, but no, it's fine for right now. Okay, 13.3 grams of magnesium chloride. Okay. So now your next step is the limiting reactant. I'm not going to actually do the problem because I'm starting to run out of time again. But a limiting reactant is when you don't have an excess. So let's say it says you only have 0.20 moles of hydrochloric acid. Well, if that were the case, then whatever you decide has to go, whatever, if it's 0.20, then this would be the limiting reactant, and you'd have to do all your calculations based on that, not the amount of magnesium. Okay, so you just have to figure out exactly what is it, what is limiting the reactant. So that's why I like the ICE tables as well, because then you can actually see, oh, well, I need twice as much of that. Okay, so that's how you would do limiting reactant. Again, you just go based from the one that's limiting the reactant, but you do the rest of it the same way. And then the percent yield. Percent yield is, of course, when you actually get a lab value, what is actually produced in the lab, divided by the theoretical. This is what you guys did in your copper lab. Theoretically, you were supposed to get out whatever your wire weighed to begin with. I think a lot of your guys' was like 0.46 or something like that grams. And then your actual was whatever you got out in the lab. So that's what you get out in the lab. So a lot of, who knows, you guys had results all over the place. But this is, again, what comes from the lab times 100. And we want close to 100%. That's the better results are close to 100%. Now, don't want to go over 100%. Why? Because then you're creating matter. Again, violating the laws of physics, what we don't like to do. Be able to talk about on the lab what would be some occasions as to why your copper was over 100%. Was it because you had extra aluminum that didn't react? Was it because maybe it was still wet? Was it just, did you just make a stupid mistake and like switch evaporating dishes? Or maybe it was equipment error, with our balances. They were, I think most of them we kind of double checked on the balances, but make sure you can talk on that. On those labs. So, okay, I'm going to give this a quit now because it's going to cut me off. But please make sure you review all these, review the stuff that we went over on Friday. Practice problems due and labs are all due by 4/20 tomorrow, Monday. Okay, good luck. Bye.